Next session is about IS-06, which is flow control, so how we're going to manage all these different video signals flowing over the network. Before we begin, just want to remind everybody that these videos will be available on VSF.TV as well as on the VSF YouTube channel, and the presentations and videos will be accessible through the IP Showcase website. Please scan your badge at the entrance and you'll get information about how to get those. So without further ado, I'd like to introduce Rob Porter and Sachin Vishwarupe talking about IS-06. Thank you.
Thank you, Wes, and thank you all for coming to the talk on using AMWA IS-06 for flow control on professional media networks. So my name's Rob Porter, I'm from Sony. This is Sachin from Cisco. Sachin's actually the co-chair of the IS-06 working group within the AMWA, and I'm a member of that working group, and we've had a lot of discussions over the last year or so on what we can do with IS-06, how we can improve it. And what we're really looking for from this talk is for more engagement within IS-06, lots of feedback from everyone. Come along to the AMWA meetings, which are online conference calls if you're a member of AMWA, or join AMWA if you're not. And it'd be great to get lots of feedback on what people want out of IS-06. But first of all, I'll go on to explain what IS-06 is. So, brief overview of the talk first. I'll start by just giving a very brief overview of what the AMWA IS-06 specifications are, and then go a bit more into what IS-06 is. I'll talk about the existing version 1.0 specification, which covers topology discovery and setting up media flows. Then I'll hand over to Sachin, who'll talk a bit about some of the future work we're currently discussing. These are things we really want feedback on: telemetry and monitoring, securing the APIs and grouping, things the specification doesn't currently do but might do in future. And then something we're currently working on, we're both going to talk about the proposed extension for network address translation. So what are the AMWA IS-06 specifications? Well, I think most of you know about ST2110, which is for the transport of the media over the network, the video, the audio, the ancillary data. That's what I'd call being kind of the transport layer. The AMWA IS-06 specifications are more about the control and management layer. So we have things like what happens when you first plug a device into the network, how does it discover, how is it discovered, how does it discover a registry and registry with it so other devices are aware of it, how do you set up connections between devices. And the AMWA, that's the Advanced Media Workflow Association, has been devising these NMOS specifications, which stands for the Network Media Open Specifications, over the last few years to do all these things. And these, particularly ISO 4 and ISO 5, are already quite mature and being used and actually being specified by broadcasters as requirements for their facilities. Some of the other ones are a bit newer. You can see demos of the event and tally specification on another part of the stand. The key thing about these specs is they're completely open. They're available online. Anyone can download them and implement them. And this is key for interoperability between different manufacturers' devices. And they're quite simple. They use standard web-based RESTful APIs using operations such as HTTP GET, PUT, patch, and delete with simple text-based JSON payloads. You can also use WebSockets, that's standard IT technology, for getting updates from over the API for when changes are made on a remote device. So IS-06, what is AMWA IS-06? Well, this relies on a software-defined networking-based model. So rather than the switches all relying on distributed messaging between the switches to create flows on the network, there's a network controller which is having overall view of what's going on the network. It's connected to all the switches. It can set up flows between switches. It's bandwidth aware of what's going on. It can authorize flows to be set up on the network. And in order to control the network, a broadcast controller has access to that network controller over the IS-06 API. So that API is northbound from the network controller to the broadcast controller. So as a broadcast controller manufacturer like Sony, we're interested in being able to use that IS-06 network control API to be able to, in a vendor-agnostic way, control networks that may be made up of one or more switch vendors' devices. The things the broadcast controller can do are things like discover the network topology and set up media flows. And I'll go into that a bit more in a moment. And it's really all about reserving and securing those network services, as I said. So those two key things. First of all, topology discovery. So on a broadcast controller, we may want to have a nice broadcast-friendly view of what's going on in the network, the switch topology, all the end devices that are attached to that switch. And using IS-06, you can get that information from the network controller using two of the API calls, the network device API call and the network link API call. And we've actually got a demo of us using this on the Sony stand where we're querying the network controller from a switch to be able to get that topology view using IS-06. So that's available today. So a bit more information on the network devices call now. So if you do a get/network devices over to the network controller, the broadcast controller then receives the information from the network controller of a whole lot of information about the switch. I'm using switch or network device interchangeably here because within the spec, network device is used to mean switch. So you get the device ID, that's just an ID for the switch, the chassis ID, the management IP address, the MTU, and an array of all the interfaces on the switch. That's every port on the switch. And then for each port, the port ID, whether it's up or down, and the speed available on that port. Then if you do a get of network links, then you get all the connections on that network. So the connections between the switches and between switches and endpoints. And for each of those connections, each of those links, you get a little bit of information about the two peers at either end of that link. That's the device ID and the port ID. So you can link that up with your topology information from network devices. For endpoints, the port ID is always null because that endpoint only has one port, and that's the way of determining that very quickly that end of the link is actually an endpoint rather than a switch. So that's the topology. What about setting up media flows? Well, again, there's another two API calls we can use for that, the endpoint API call and the network flow API call. So let's consider how these fit into the ISO4 and ISO5 workflow. So on the right there, you can see a pretty basic diagram showing a professional media network. So we've got our network infrastructure in the middle there, represented by a single switch. That could be an entire leaf-spine network made up of multiple switches. Connected to that, we have a series of media nodes, or endpoints in ISO6 parlance, consisting of various cameras, monitors. It could also be vision mixers. It could be combinations of senders and receivers within a single media node. And then we've got our ISO4 registry connected to that network, a broadcast controller, and also, because we're living in an SDN world here, we've got an ISO6 network controller there. So just briefly going into how ISO6 fits in with ISO4 and ISO5. When you first connect a media node to the network, with ISO4, what it will first do is use DNS to discover all the registration API services available on that network. And then it will connect to the registry and register itself and all its sub-resources. So that's the node, the device, the sender, the receiver that are all associated with that single media node using the ISO4 registration API. Now that there's some new information on that registry, assuming the broadcast controller, or NMOS client, is connected to that registry over WebSocket, so it's subscribed to updates from the registry, the broadcast controller will immediately get an update from the registry over the ISO4 query API saying that there's a new endpoint on that registry there. Something new's been connected to the network. The new bit here using ISO6 is that we then use the ISO6 endpoint API to let the network controller know about that new endpoint connected to the network that the registry already knows about. And it will give it information such as the IP address at the end of the endpoint, whether it's a sender or receiver, or it's capable of doing both, and a unique ID. And also, crucially, the chassis ID and the port ID that endpoint is transmitting over LLDP, which lets the network switch be aware of it as well. And that means that the network controller can then determine exactly where that endpoint is connected to the network by tallying up that chassis ID and port ID information with the information it knows already from its own switches. So it will know exactly what port and what switch that endpoint is connected to on the network. And that's useful for when you're setting up connections. So the traditional ISO 4 or ISO 5 mechanism for this, so the client would use the node's ISO 5 connection API, which it knows about from the ISO 4 information from the registry, to initially get a transport file from the sender. It would then patch that transport file to the receiver, and then without ISO 6, what traditionally happened was the receiver would issue an IGMP join to the network, and the connection would be made, and it would be using the multicast address that it knows about from the SDP file, from the transport file, to do that. So the problem with this kind of non-SDN approach is that there's no authorization or bandwidth control there. You could have rogue IGMP joins coming from things on the network, and the network would just allow multicast packets to start being forwarded to that receiving device without any kind of awareness of the bandwidth requirements or any authorization from the broadcast controller necessarily. So that's where ISO 6 solves this issue. So with ISO 6, rather than relying on an IGMP join, we're making an explicit request from the broadcast controller to the network controller to set up the flow. And so we're giving that network controller the information of the sender and the receiver and the multicast address and so on. And then the network controller, if the bandwidth is available, can set up that flow from the sender to the receiver, and a connection is made. If we still want to use an IGMP join from the receiver, just to let the receiver have some control of when it starts receiving those new multicast packets, the option is there to still do the IGMP join. So you can choose to start forwarding the flow immediately, or you can wait until the IGMP join. Those are two options within ISO 6. So some of the benefits of using ISO 6 for flow control: the flow setup must be explicitly requested by the client, by the broadcast controller. So there's some kind of inbuilt authorization there. No rogue IGMP joins are allowed. The network controller can ensure sufficient bandwidth is available because it has that overview of the entire network. So it ensures the network's not oversubscribed. So previously, you may have had to over-provision your network to make sure it's completely non-blocking from every possible sender to every possible receiver. Whereas now we can allow the network controller to have a bit more control over it, maybe prioritize some flows, stop some other things happening on the network to allow other flows to happen, and make it a bit more of a flexible, more cost-effective system. And also, crucially, as I've mentioned, it's an open multi-vendor approach, so we're not relying on a single switch vendor's network protocols. We're using ISO 6 instead. So I'll hand over to Sachin now to talk about some of the new areas we're considering. Thanks.
Hello. Thank you, Rob. So what Rob has gone through is setting up a flow and actually establishing the endpoints. What we are looking into right now is how do we take this forward? Because when you set up the flow, you are giving the intent to the network controller, platform agnostic way, and saying, hey, set this flow up. But there are multiple issues in that, right? Some of these vendors actually may do it in a delayed fashion. They may accept the request and subsequently find the optimal path. Or some of them can do it in a synchronous way. So we need to introduce a feedback mechanism by which we can at least know that the flow is established or there was some issue. And even if it is set up like initially, there's a possibility that at later point in time, if there is a node goes down, like a switch goes down or a link goes down, there is no sufficient bandwidth in the network, or there is no path from sender to receiver, we need to provide a feedback mechanism. So this is something we are considering for the next release. Another thing is, even though we are doing kind of a non-blocking way, so we are guaranteeing the bandwidth for the flow, there's a still possibility in the network that you are dropping some of the traffic. So we would like to provide the statistics for all these flows. So that's the part of flow statistic where you can get the active as well as drop traffic. What Rob was talking about, we have the IS-06 where you can get the physical topology of the complete network. But if you talk about individual flows, there's a logical topology. If it is a spine leaf network, you may have a particular spine and the flow is going through that. It can be just one hop away. It can be multiple hop away. So most of these broadcast controller, they are very much interested to know the topology of individual logical flow, and that's what we are going to expose. The next one is the classification part. So if you think about it, you are giving the intent saying, I have a sender, I have a receiver, set this flow up, but it's possible that camera is turned off. So that flow is essentially a receiver only flow. Right now it is still waiting for the sender. Or the other case, maybe you have a sender streaming the data, but you don't have a receivers which are online. So you need to get that kind of visibility. So you may have an active flow or sender or receiver only. And the last possibility is you may have sender and receivers. Both are online, but there is no sufficient bandwidth in the fabric of the network, and so those are inactive. So that classification is something we are going to expose. The next point was the endpoint. So as Rob was talking before, you may statically configure those endpoints under the network using the API, and some of them may be dynamically discovered through IGMP. Obviously, the permit will happen only with the API, but if you want to get that visibility, how this endpoint is attaching to the network is something we will expose as well. Now, when we show the topology of the network, it's very critical to know what is the state of those nodes, like switches or the links, and that's what we are going to provide. It's also important to know aggregated as well as individual usage. So for a given switch, if you are doing a kind of a capacity planning, you want to know how many flows are going through that, how much bandwidth is taken, and this can be at the switch level or it can be up to the link level. So that's another part of it. So what I'm talking here is the monitoring aspect of the IS-06. The second aspect is the telemetry. So telemetry is essentially you are streaming the data, right? So you can get the state of the network through monitoring APIs, and what we are trying to provide is the telemetry to give you the current state as well as statistics. So the first portion, as I was talking before, is you would like to know what are these flows and what are the current stats on those flows. Also, if they are denied for some reason, so example, the network vendor may have some security policies in place, and that may actually deny some of those flows. So you would like to know all that information, which we will send this out via telemetry. Now, there are multiple options available for that. It can be MQTT, it can be WebSocket, it can be a Google RPC. So we are exploring all these options. Probably in this case, Google RPC or WebSocket makes more sense, but this is fundamentally very important if you want to know the current statistics of the network. And the last one is, in a timely fashion, you would like to know the network changes. So if the links are going down, if you have set up certain thresholds, so in many cases, you would like to set the threshold on the links and on the switches. So if it reaches, you don't want to wait till the switch is fully overloaded or link is overloaded. So we will provide custom threshold on the switch as well as on the link, and those can alert the end user. So this was the part of like a statistical and monitoring and telemetry aspect of the IS-06. The other portion which are there in some of these IS-06 and ISO standards, but not for IS-06, which we would like to use, is BCP 003. Essentially, the current APIs are unsecure, but we can definitely piggyback on the BCP standards to the security portion of it, and that's something we are exploring. In the studio, in the broadcasting world, as all of you know, right, there will be a salvos. So you are not actually bringing a single sender or receiver. You are setting up the show or tearing down the show. So what we would like to do it is use the logical grouping where A-10 or -7, you have audio, video, caption, like ancillary data. That's one group of it. And there may be multiple such endpoints going together. I mean, you can call it as a salvo, you can call as a logical batch, but essentially you would like to fire this in a transactional fashion. So when you are setting up the show, you want to make sure I'm not only setting up the audio, but if there's not enough bandwidth for video, there's no point in setting up that flow. So we can alert, as well as we can give you a construct to set the flows accordingly. And here, there is a possibility we can explore the possibility of leveraging BCP 002 because it already has a grouping tag construct. So the next one, Rob will quickly go over the use cases of why we are getting into the NAT, and then I'll go into the actual implementation details. think so.
Thanks, Sachin. Yeah, so something we've currently been working on a proposal on is this proposal to extend IS-06 for network address translation. So this is where within the switch fabric, we want to change the multicast address on certain packets. And there could be various reasons for this. So we've got a few different use cases listed here in the AMWA use case language that we're encouraged to use. So as a facility owner or a broadcaster, we'd like an open way of applying network and port address translation. And this could actually be to multicast packets or unicast packets. Within the network fabric, one use case is to be able to share resources between facilities in a flexible way. Those two facilities, that they may be on remote sites, they may have different addressing schemes, and we might want to be able to subscribe to a sender on one zone from another zone and be able to bring that into the same addressing scheme. There might also be address conflicts between the two zones, so we might need to do address translation for that reason. Also, you can have receivers, be they contribution encoders or decoders or legacy devices, such as some audio devices, that are tuned to a specific multicast address and can't easily be changed without kind of getting onto that device and configuring it manually or using some proprietary protocols. So instead of having to change the multicast address that the device is receiving on, we could do that multicast address translation within the switch fabric to do that and have control of that from our broadcast controller. Finally, there may be some general network monitoring or packet capture equipment that we want to direct all the flows in our network to do some monitoring, and this would be a nice, simple way of doing that without it having to subscribe to every multicast group, which it may not be aware of. And again, the final point here is we'd like it to be an open method so we can use the same approach across different manufacturers, switches, and network controllers.
Thanks, Rob. Thank you, Rob, again. So it's still in the draft stage. We are working on it. And where we are today, these are the design goals, what we put together for the NAT functionality. Fundamentally, we are extending the current IS-06 for that. So for example, you already have endpoint in place. Now you want to do the translation, we can piggyback on that. The idea is to have a separate object model for the NAT. The reason being, if you choose not to implement day one, you can do basic IS-06 and then add on to that for the NAT functionality. When we say NAT, we are talking loosely, but it includes IP address and port address. So this can be ingress NAT or egress NAT, source NAT or destination NAT, whatever the term you choose. Typically, you would find the UDP, RTP-based traffic, but we would support both TCP and UDP from the design perspective. And the policies can be per interface, or the scope can be entire switch or device. The other thing what we would like to do it is, this is a conditional translation. So you don't want to change every single group, but you may have certain condition. You are matching, let's say, source side or a destination side. I have a next slide which can give you a little bit more details on that. And you can change both. You can, when it is received by your receiver, you can change the destination or actually a source as well. And the last but not least is vendor neutral. So we have the draft right now, and if you stop at Cisco booth, we are showing this where you can change the source and it can receive to the fixed destination. And this is what we have. Now this is the example of all the possibility, all the permutation and combinations you'd like to do to achieve the NAT. So as you can see in the match condition, you can do a source. In the source, you can have an IP port. The same goes for the destination where you can have IP port. So what essentially we are saying here is, if you match all the 4 parameters in the header, then only do the translation. Now, if you see the translation, we are translating all the 4 parameters here. So whatever the incoming source is translated for the IP and port, and so is the destination. And this can be done selectively. So these endpoints are the one which you actually inputted through IS-06, and you can apply to this some of the endpoints, and others can just get the raw data. The simplistic case, what Rob was mentioning is, you just want to translate. So whatever is coming for that endpoint should go to the fix. So there are certain endpoints which are not capable of dynamically changing the group. They can just listen to a fixed IP or port, and we will do the translation for them. And this can be done depending upon the vendor, like at the line rate. So it's essentially they will get the exact same capability without configuring the endpoint. It just listens to the same condition. Yeah, so this is basically saying that the post request or any of the REST URL or URI can be applied at the entire switch or a device level, or the scope can be per port. So essentially what we covered is, Rob covered the IS-06, maybe you want to come back, and we talked about the enhancement. What essentially we are looking from all of you is the active participation. We welcome any kind of feedback on this, and we are in early stage, so please contribute, and together we can make it successful.
Yep, thank you.
Thanks.
Thanks, Rob. Thanks, Vishwa. Do we have any questions? Any questions at all? No, you're just waving. Okay, great. So thank you very much, and we will go on to the next presentation.